Ladies and gentlemen, today we're going to be talking about multiplying and dividing to solve equations. We're going to be looking at a specific type of multiplication where we have to do what's called applying the multiplicative inverse. That sounds like a crazy word, multiplicative inverse, to solve equations. It's not really that crazy uber special like finding a unicorn at the end of the rainbow, but we're going to be looking at how we can use this skill to solve equations today. So we always know that when we're solving equations to find x, we need to isolate the variable, which means get it by itself using inverse operations. So if I'm adding to x, I'm going to subtract that value on both sides. So we need to remember to do these to both sides. If I'm multiplying, then I do the opposite and vice versa. So this example would be 3x equals 18. If I'm multiplying by 3, I need to divide by 3. If I'm adding 3, I need to subtract 3. Okay, so it's doing the inverse to get x by itself. So it's pretty simple when I get to something like this. 3x equals 18. I'm multiplying 3 by x, and so I divide by that. So I divide by 3. Both sides cancel out. And now I got x equals 18 divided by 3, which is 6. No big deal. The problem comes when I have a fraction to deal with. So I still need to approach it the same way, but as you're going to see, we need to do an extra step. So here's how that looks. And I'm going to divide this. Because I'm multiplying by 2/3, I need to divide by 2/3 to get it by itself. So now, if I do that to this side, I must do that to the other side. So these cancel. And I'm left with x equals 8 over 1 divided by 2/3. Now, if I look at that, I can't just divide this. I need to do an extra step. When I divide by a fraction, I'm doing what's called multiplying by the reciprocal, which is like flipping the fraction. So you may have seen this before. This whole process here is called the multiplicative inverse. I multiply by the inverse of that fraction. So another way of looking at this is we do the inverse. I divide by 2/3, and then I do the keep, change, flip. We remember that from Unit 3 when we talked about dividing fractions. I'm going to draw that in blue. Okay, so I keep the first fraction, I change the sign, I flip the second. So our next equation simply becomes 8 over 1 times the inverse, or the reciprocal, which is 3/2. So the inverse is 3/2, so I get 24 over 2, which converts to 12. Okay, over 1. And so I need to remember there are two steps to this. I do the inverse to both sides, and then if I'm multiplying by a fraction, I need to remember to do the multiplicative inverse. I multiply by the reciprocal. Multiplicative just rolls off the tongue. So let's take a look at this. I have isolating the variable using inverse operations, and then I keep, change, flip. Okay, so I have 4/5 times y equals 20. So if I'm multiplying y times 4/5, I divide by 4/5. I need to do the inverse. And if I do it to this side to balance, I must do the same thing over here. And so I end up with y equals 20 over 1 divided by 4/5. And so I do the keep, change, flip. And this turns into y equals 20 over 1 times 5/4, which ends up becoming 20 times 5 over 1 times 4, okay, which would equal 100/4, or 25. Okay, so when we're multiplying a fraction, when we want to get what y is by itself, we perform what's called we multiply by the inverse. So we first need to isolate the variable by doing the inverse. So instead of multiplying by 4/5, I divided. Second step, I do the keep change flip. Now I'm doing that, and I simplify it to get to 25. So that's how we deal with fractions when we're solving to get our variable by itself.